Hey, algebra friends, we are on lesson 2, function notation. Sorry you can't see my lovely face, but I am having camera issues with my computer. So hopefully we'll get that adjusted soon, and maybe next video you'll see my lovely face. But for now, you can just listen to my beautiful voice. So we're talking about function notation today. A function is a rule that takes an input, does something to it, like some sort of calculation, and then gives a corresponding output. The special notation is called function notation, which kind of makes sense because we're talking about functions. And what we're going to get used to, we're going to get you used to using function notation instead of y equals notation. And that's really the biggest difference. Function notation is a way for math teachers to tell you to use substitution into an equation without having to write out the words substitute into this equation. And I'll explain to that as we go through this lesson. The special notation called function notation that's used to represent this situation. If the function name is f, you can use any letter, but lots of times mathematicians will use f for a function because the word function begins with f. The input, the domain, the independent variable, that's the x, and the corresponding output is the y values. So we still have x's and y's, but instead of a y equals type equation, it's going to be f of x equals. So the notation with f parentheses x is read out loud as f of x. That's how you read this. So the notation f of x, that's f of x, is read as f of x. F of x is used to replace y in the rule. So, for example, if you were given an equation y equals 2x plus 6, the function version of this is f of x equals 2x plus 6. So it's just a different way of looking at the equation and writing the equation. So we're going to go through and practice the notation and some of the things that it means. When you use functions, you can see functions written in table form, graph form, or as an equation or rule. If you're looking at a table, notice that we have a column with the x's, and then instead of y, it's f of x and g of x. That means these are two different equations that generate the points. One of them is named f of x, one of them is named g of x. In the notation, when you're asked to find f of 1, that means you're going to go to the f column for function f and find where x is equal to 1. The number that's in the parentheses is the x value that you are being given. So you're being told that x is equal to 1, and you are being asked to find the y value that goes with it in the f column. So we look for where x is 1, and we go into the f column, and we see that f of x is negative 4. So then in the f function, when x is 1, y is negative 4. The next one, it says find g of 2. That means we're going to go into the g column and find where x is equal to 2. So remember, the number in the parentheses is the x value. So we are going to go to where x is equal to 2 and look in the g column this time, and we get negative 6. So our y value would be negative 6. This would technically give us coordinate points. So for the first one, with f of 1 equal 4, that means I would have a coordinate point where x is 1, y is 4. For the second one, g of 2 equals 6, that means I would have the coordinate point where x is 2, y is 6. If they ask us to do f of 0 plus g of negative 2, you're going to do the research in the table to find where f of 0 is. So that means look in the f column where x is 0, and you get a y value of negative 1. So that would be negative 1 here. And then in the G column, go to where x is negative 2, and the y value would be 0. So then this would be 0. And we are supposed to add them together. So negative 1 plus 0 is negative 1. So we would just evaluate or get the y values for each of those given functions. Evaluate function f when x is 0. Evaluate function g when x is negative 2. And then add the results together, which is what we did here. So that's what we would do from a table. If it's from a graph, we're going to do the same kind of thing. The function g of x is explaining or giving a name to this picture. So when it asks for g of negative 1, that means you're given the x value of negative 1, and you want to find the y value that would go with it. So on the graph, you're looking for the point that has an x value of negative 1. What's the coordinates of that point? So that would have a y value of 3. So g of negative 1 is 3. When they ask for g of 4, you're going to go to the graph. You're going to go and find where x is 4. And what's the y value at that point? And the y value there would be 0. Because that would be the point 0, 4. I'm sorry, this would be the point 4, 0. So the y value is 0. This would be the point negative 1, 3. So the y value is 3. So they're asking, what is the y value when x is negative 1? What is the y value when x is positive 4? So why don't you pause the video and answer question A, and then I'll help you with question B. So for question A, they want to know what is the y value when x is 3. Oops, that should say 3. So when x is 3, 1, 2, 3, when x is 3, go down and see a y value of negative 2. Now the last one here, this is a little backwards. This one is asking you to find x this time. Find the x value that gives you a y value that's equal to 1. So find x when y is equal to 1. We can still use the graph. We're just going to go and find the y value of 1 and find an x value that goes with it. So we have two different x values. So when y is 1, x can either equal negative 2 or x can equal positive 1. So we could do it either way. And that is okay. Now, how does this work when we have a rule or an equation? Well, basically what you're going to do is plug the number into the equation and then go to your calculator and do the calculation, or maybe mental math if it's a simple function or a simple equation. So let's do a couple of these. Each point we typically call xy. Because the y value is using now a new notation, we can call it x comma f of x, because f of x is equal, that's the same thing as y. We're just using almost like the substitution for y and making it f of x instead of y equals, f of x equals. So this says f of x equals negative x minus 15. That would be the same thing as saying y equals negative x minus 15. Just a different notation. When you have f of 4, what that is telling you to do, it is notation, it's lazy mathematician notation to say plug in 4 in for x. Okay, so we're going to take our function, f of 4, and we're going to plug in 4 in for the x value. Then we go to our calculator. What is negative 4 minus 15? We get negative 19. And we do that for each different number that they tell us to use. So the next one, it says find f of negative 10. That means I'm going to plug in negative 10 everywhere I see an x. So negative x means I'm going to negate the negative 10. Negating a negative 10 turns into positive 10. And 10 minus 15 is negative 5. And then we keep going. F of 0 means substitute 0 in for the x. So f of 0 means put in 0 in for every x that you see. And then just do the math. Negative 0 is just 0. 0 minus 15 is negative 15. So there's some other vocabulary that goes along with that. X's are the inputs, Y's are the outputs, but we also use the words domain and range. So domain and range, domain means the x values, the inputs of a function. The range is the y values, the outputs. And remember I said in the last video, domain alphabetically comes before range. So because D comes before R and X comes before Y in the alphabet, domain is the X's, they both alphabetically come first, and then range is the Y's. That's one way you can help yourself remember it. So what we're supposed to do when it asks you to find the range given the domain, what they're telling you is that the X values that you are supposed to use are the numbers negative 4, 0, and 8. And you are supposed to find the Y values that would pair up with each one of those X's based on the given equation. So I have this equation, g of x equals x squared plus 2x minus 1. I have X values, numbers to use in for the X's. Plug each number in one at a time, do the calculation, and find the corresponding Y value for each of those X's. So let's start with the first one. We use an X of negative 4. So g of negative 4 means to plug in negative 4 in for each X. You put the same number in for all the X's that are in the equation. Now you can go to your calculator and type this all in at once. And then just hit enter. Make sure you use parentheses around all your values. If you want to do it step by step, negative 4 squared means negative 4 times negative 4. That's positive 16. 2 times negative 4 is negative 8. And then we have a minus 1 there. And then 16 minus 8 minus 1 more is 7. So that is the first element or first number in our range. That's the first Y value that we get when we plug in our first X value. So that would make the coordinate point negative 4, 7. The X value was negative 4. We plugged it in, got a Y value of 7. Next number. We are supposed to plug in 0. So let's plug in 0 and see what we get. So we do g of 0. That means we have 0 squared plus 2 times 0 minus 1. 0 squared is 0. 2 times 0 is 0. 0 minus 1 is negative 1. That would give us the coordinate point when x is 0, y is negative 1. And we have one more to plug in. So let's do this dark green. We are going to find g of 8. So we're going to plug in 8 in for all the x's. So it's 8 squared minus 2 times 8 minus 1. 8 squared is 64. Negative 2 times 8 is negative 16. 64 minus 16 minus 1. I mean, that should be a plus 2. So 64 plus 16 is 80, minus 1 is 79. So again, that would give us the coordinate point with an x value of 8, a y value of 79. Now the question asked us to find the range. So when we answer our question, the range is the list of y values that we found. So the smallest y value is negative 1. Then the next was 7, and the largest was 79. You do not have to put them smaller to larger, but that's usually how you will see it on a multiple choice question. The order doesn't matter, so if it's different from the way you write it, it's still okay as long as the numbers are the same. All right, example number 5, and we're almost done. Example number 5. For f of x equals the equation negative 8x plus 27. This one says find x. So that means we're solving for x. If we're solving for x, then the negative 13 goes in place of the f of x. So the equation that was given was f of x equals negative 8x plus 27. If f of x is equal to negative 13, then this f of x turns into a negative 13. And now we're going to solve for x. So my first step in solving for x is to subtract 27 from both sides, because I want to get the x alone. Negative 13 minus 27 gives me a negative 40. Bring down the equal sign, and I still have negative 8x over here. Divide by negative 8. And negative 40 divided by negative 8 is a positive 5. So why don't we let you try this next one, the last one here. It says f of x equals x plus 2, and h of x equals negative 9x squared plus 6x. That's two different functions, two different equations. When you want to find f of 1 plus h of 3, plug 1 in for x into the f function, plug 3 in for x into the h function, and then when you're done, take those two numbers and add them together. So why don't you pause the video, take a minute or two, see what answer you get for that, then come back. Please. Go do it. So when I plug in or try to calculate f of 1, that means I'm putting 1 in for x into the f function. That gives me the number 3. When I take 3 and put it into h, I put 3 in for each x, put the same number 3 into both x spots. I go to my calculator. 9 times 9 is 27, plus 18 would be, I'm sorry, 9, let me get this out for you. 3 squared is 9, 6 times 3 is 18, negative 9 times 9 is 81, negative 81, plus 18 is negative 63. There we go. So now what we're supposed to do, according to the original question up here, is add the results together. So if I want to do f of 1 plus h of 3, f of 1 we figured out was 3. H of 3 we calculated as negative 63. So 3 plus a negative 63 would be the same thing as saying 3 minus 63, which is negative 60 as a final answer. And if you got that on your own, fantastic, good for you. And if you didn't, it's okay. We're going to practice it and get better at it. And our last one, let's end with a nice shade of blue. We are doing 2 times f of 5. So we're going to take 2 times whatever number we get when we put x, or we put 5 in for x into the f function. So f of x equals x plus 2. We're using 5 in place of the x, so it becomes 5 plus 2. So it's 2 times 7, which is 14. And that's it for this one. Kept it under 20 minutes. Enjoy the rest of your day. Take care. Peace out. See you.